There are some tools that are really, really expensive and high tech, but then there are some really easy methods that are just free. And I think it's important for everyone to know that you don't have to invest in a really, really expensive system to start monitoring your moisture in your soil.
In this episode of Voices from the Field, NCAT Sustainable Agriculture Specialist Katherine Favor talks to NCAT Southwest Regional Director Mike Morris about a new series of irrigation guidebooks available from NCAT's ATTRA program. Mike and Katherine discuss some common myths and misunderstandings about irrigation, the underappreciated importance of soil health to irrigators, and some easy and inexpensive thing every irrigator can do to save water, energy, and money. Let's listen.
Western megadrought, California floods, reservoirs going dry, declining aquifers. The topic of water conservation and management has been in the news quite a lot lately, and irrigators all over the country are struggling with uncertain water supplies. There's more competition than ever for scarce water, and we need to talk about it. So today we're going to have a conversation about irrigation efficiency. My name is Katherine Favor. I'm NCAT's agroforestry specialist out here in California. And today I'm joined by my colleague, Mike Morris, our Southwest Regional Director, who has just updated 2 water and energy conservation guidebooks for irrigators and has made them available as free ATTRA publications. Hi, Mike.
Hey, Katherine, good to be here.
So water efficient irrigation is crucial for both environmental sustainability and also optimizing crop yields. Can you tell us a little bit about your experience working on irrigation and water conservation?
Sure. The first thing I would say is I'm not an irrigator myself. I've irrigated gardens and the occasional, front yard, but I'm not a real irrigator, nor am I an expert. But I have had a real interest in irrigation over the past couple of decades, and I had the chance to work with a lot of people who really are experts, as well as hundreds of irrigators. Mostly this started when I was running a pump testing, an irrigation efficiency program for an electric utility in the state of Montana. We did a lot of pump testing on irrigation operations, and we did a lot of soil moisture monitoring on close to 100 farms in Montana. So in the course of that, I did get to talking to a lot of people. I met a lot of educators and agency staff and people who are interested in water as well for a variety of reasons. And then just within the past 6 or 8 years, as you know, Katherine, we've started this program at NCAT called the Soil for Water program. That's also a program about catching and holding water in soil. And through that program, again, I've been pulled back into the orbit of irrigation. And I did want to flip it back to you because you actually have run irrigation systems on farms, and you have way more firsthand experience than I do. So tell us a little bit about your experience out in California.
Yeah, so, being in California, irrigation is just a part of farming. You cannot farm without irrigation out here. We get 13 inches of rainfall out in San Diego every year. And so it's just a really crucial part of being a farmer. And my experience, I was a grape farmer, a wine grape farmer. And so quality is of the utmost important when you're growing wine grapes. And so you really, really have to dial in how much irrigation you're applying to your grapes and when. And so precision irrigation was just, that was a part of growing wine grapes. And so that's kind of my experience. But there's still so much to learn. There's so many different types of irrigation systems. And that's why, I've really been impressed with these new books that NCAT has put out, the Micro Irrigation Pocket Guide, because it's just an incredible resource that can really teach growers about all of the different facets of irrigation. So yeah, if you could tell us a little bit about these books that you developed, about these irrigators pocket guides. What's in these books and why did you decide to update and reprint them?
Sure. Well, we're really excited to be reprinting this book. It's a new version of a publication that started back in the late 1980s, I believe. And it has been reprinted now, I bet 15 times. NCAT has continued to update it as we've learned new information. So it's gone through a lot of evolution. It's a small format book, about 4 by 6 inches. It was sized to fit into a hip pocket. So the intent was always a very, very practical, very concise book that would sort of cover the nuts and bolts of what you really need to irrigate well. One side of it is equipment maintenance and goes through all the very specifically how to maintain pumps and motors and distribution systems step by step, including for beginners who are not that experienced with irrigation. And then if you flip it over, it's got a section on water management, which covers all the many ways that you can decide how long to run your system, how much water you actually need to apply, what your crops need, and all that, which is often lumped under that heading of irrigation scheduling, timing irrigation for the optimal crop yield. And in the middle of the book, we put formulas, all those things that irrigators need to know to calculate flow rates and pressures and volumes and all that type of thing. Again, super helpful, super concise. So it's sort of a no-nonsense guide. It's made very concise. I always credit NRCS because they funded us to reprint the book, now 15 years ago, and have funded a number of the versions we've done in so many Western states, but also because we've always checked our work against the NRCS Irrigation Guide, which is a really comprehensive technical manual, and we'll put a link to that in the show notes. Anyway, that's a quick version of how the book came to be and how it's grown and how it's evolved. Two things I would say we set out to do is, one, to demystify irrigation for those who find it a little bit intimidating, and give people encouragement to jump in there and run these systems and learn how to run them, which anybody can do. And the second thing was to give you a variety of methods. So rather than say there's one right way of doing this, you have to do it this way, what we do is give you a kind of a smorgasbord of good strategies you can use to manage your systems.
Well, and I love, just going through the table of contents, it really does cover all the basics. It talks about micro irrigation basics, determining how much water to apply, determining your application rate, and how long to run your system. I mean, these are the questions that irrigators ask every day. And before we go any further, I guess we should say how listeners can get free copies of these books. So on our ATTRA website, you can order them, and we can actually put a link in our show notes as well. So yeah, they're available.
It's a nice little free publication. Keep saying the word free. We want these to be out. And again, that's thanks to the USDA Natural Resources Conservation Service, which funded this latest reprint.
Yeah, thank you so much, NRCS. And so, Mike, boil it down a little bit for us. What are the essential things that all irrigators should be doing?
Sure. Well, I'll lay it out the way we do in the book, which is really basic. Maintain your equipment. Take good care of soil health. Check your soil moisture. Know how much water you're applying, and then know at least basic watering guidelines for the crops that you're growing. And we could say more about all of those things, but those are things that I think are essential. All irrigators need to do those things. I'll just touch on a couple of those things real quick. The first is taking care of soil health. That's really the reason we decided to reprint this book, as I think you know, Katherine, because there has been an explosion of understanding of soil health in the past decade or two, what some people have called a soil health revolution. And so we really do know a lot more now than we did even a couple decades ago about how soil holds water, and we know how much you can increase the water holding capacity of soil. In the older versions of the book, we did have a good coverage of soils and soil types and a kind of a basic overview of soil science, but we didn't say a whole lot about how to increase the water holding capacity of soil. So this is something that's lacking in a lot of other older textbooks. It's sort of a new angle, but something that we think is absolutely essential for all irrigators, and often the most cost-effective thing you could possibly do is if you have healthy soil, everything in irrigation gets easier. Your soils are holding water, they're holding it longer, and so we make a big pitch for that in the book. We offer a variety of ways of doing that, as does the whole ATTRA website, as you know, Catherine. We
Right.
now have lots of good help for folks in terms of improving soil health, and so it's just so important. And then maintaining equipment, which really goes hand in hand with management. You really can't run a system very efficiently if it's not running right. So if your system is out of whack, or the parts don't work well together, it's much harder to run that system efficiently and precisely. So management
Absolutely.
and efficiency and maintenance, basic maintenance, are really two sides of the same coin.
And I love that you talked about soil health because that really is the base of everything. That's step one. When we create healthy soils, when we create a healthy soil structure, it can capture and hold more water. And that just means we have to apply less, there's less erosion. It's just better for the whole system. So I think it's really important that you do touch on that in this book.
For sure, yeah. And then the add-on, which is recommended, but harder, is actually to track those evapotranspiration rates. When we talk about evapotranspiration, we mean the combined effects of evaporation and the transpiration of water through the plant leaves. That process of using water, taking it out of the soil. So as you get more sophisticated, you can actually track and calculate, estimate how rapidly water is leaving the soil, and then try to add exactly the amount of water that your plants are taking out. And you know, Catherine, I might give you a chance to plug a publication you and I did together called Soil Moisture Monitoring Low Cost Methods and Tools and Methods. Because one thing we noticed in a lot of the irrigation guidebooks out there, it's almost like they start with the hardest things and the most expensive things first. And so we always want to start with the things that are easiest and the things that are the least expensive.
Right. Because it's true, there are so many different tools out there for monitoring soil moisture. And there are some tools that are really, really expensive and high tech, but then there are some really easy methods that are just free. And I think it's important for everyone to know that you don't have to invest in a really, really expensive system to start monitoring your moisture in your soil. You can if you want to, and you can if it makes sense for your growing context and your market, but that's not required at all. And I think yeah, the most important thing is just to get out there, to start monitoring at some level, just get to know your soils and go from there. And I love that publication that we wrote because we kind of went through all the different levels of technology that you can use to monitor soil moisture, from super low tech to super high tech and everything in between. And there's something for everyone, really, just depending on what your goals are and your resources. And maybe we can talk about some of those different tools that we can use to monitor soil moisture. Like we mentioned, there's some super low tech ones.
You know, it begins with something as simple as a shovel. And for those who just simply occasionally dig into the soil and see how it looks, see where it looks wet, how deep the water has penetrated. While you got the shovel out, of course, take a look at your root zone and see how deep your roots are actually going down into the soil, which is so important and so helpful. Something we found super helpful is a push rod, which you can buy one for $50. A lot of people just make their own with a piece of a scrap metal rod you might have lying around. Better if you can put a T-handle on the top, but just pushing it into the ground, and these will sort of stop, and you'll feel that resistance when you get down through the moist soil and you hit the dry soil. Very inexpensive. For a lot of people, that is absolutely all that they need. And just to give me an idea of, is the water down there, is it 6 inches in? Did it go down a foot? Did it go down 2 feet? That is extremely helpful information. I want you to talk about tensiometers because you know a lot more about them than I do, but you can make your own for under $100, and they're another pretty low tech strategy. The farthest we went really up in the technology scale was again when I was working with a lot of irrigators in Montana, mostly growing alfalfa, which is a very deep-rooted crop. They really enjoyed having a data logger, which for listeners who don't know is just pretty simple device. It sends a weak electric current out through some wires. It's usually powered with batteries, and you have sensors buried in the soil at the end of those electrodes, and you can read off the approximate soil moisture. You can bury those sensors at different depths. These are systems you could probably put in for maybe $500 if you want to go on multiple sites and multiple sensors. You could be getting up towards $1,000, somewhere in that range. But now you're getting a lot more precise information, which can be really helpful if you're growing a higher value crop. But why don't you talk about tensiometers?
Well, tensiometers are kind of similar to that idea. You bury these tubes at different depths of your soil, and they have a ceramic tip, and they're airtight. And what they're doing is they're measuring water tension. They're really, really cheap. Relatively speaking, they're $150 to $200 each. So it's an investment that it really pays off fast, especially if it does help you save in water costs. Out here in California, water is very expensive, and so something like this really pays for itself relatively quickly. And to be honest, same with data loggers. Data loggers are a little bit more expensive, but they're also a little bit more precise. I would say tensiometers and data loggers are two really, really great kind of mid-tech solutions that could be great investments depending on what your crop is, and depending on where you are and how expensive your water is. And then, like you said, Mike, there are some really high-tech soil moisture monitors as well. And those are things like neutron probes and pressure chambers and pyrometers, which measure stomatal conductance on plant leaves. You can measure, you can use infrared satellite imagery. And there are even, for perennial plants, there are sap flow sensors that you can actually install in your perennial vines and trees to get 10-minute interval measurements of the exact amount of water flowing through a plant's vascular system. But of course, those technologies are very expensive, and they really aren't necessary for the majority of growers. That's really if you're focused on a very, very high value crop that needs to have a specific quality. So, but it's neat to know these tools are out there. You can do super low tech tools or super high tech tools or anything in between. There's really something for everyone. And it's just nice to know about the different tools in the tool belt, and then you can kind of pick and choose depending on what works best for you.
For sure, yeah. Convenience is so important. Again, looking around at what's there. If you can automate that process, which is what a data logger does. A data logger will check your soil moisture. You could set it every 10 minutes, 3 times an hour, however much you like. That can be a real time saver, and it can give you really high quality information. Some people really like just a handheld probe, not just a push rod where it's just the resistance of it, but something that actually has a sensor at the end of it that you can go anywhere in your field, push it into the ground, and it'll read off moisture. These are, again, things you might be talking about a couple $100. So there's quite a range, but then that can become a little intimidating too. There's so many things out there. How do I know what to do? How do I know, which is the right one? I would encourage people to, try something inexpensive and see what you like, and do a little bit of reading on this. What we make a pitch for in the book, and I guess when I talk to irrigators, is, yeah, it's okay to just do what the neighbors do, and it's probably not bad, and it might be putting you in the right ballpark. But the more you can actually take control of your own system and really know how it works and know how much water you're putting out, know what your plants need, you're really honing in on that, and you'll begin to see those benefits in your yields and the quality of your product, as well as saving water and saving money, because pumping water, of course, costs money.
Yeah, it's so true. These are really important tools, and they can save farmers money. And one thing that I want to go back to that you mentioned, Mike, is this idea of tracking evapotranspiration and what that involves. And I know that the book really covers that in detail. Can you talk a little bit about what it is to track evapotranspiration and how you can incorporate crop coefficient values into that calculation as well?
Yeah, sure. And this is traditionally one of the things that often is taught to irrigators. It's often featured in the guidebooks you might be seeing. if you're just browsing through all the websites, and there are hundreds of websites, including many really excellent ones on how to manage irrigation. A lot of extension agents specialize in irrigation, and yeah, the basic idea is you want to estimate how much your crop water use, what rate your crops are using water, which is based on this combination of evaporation and transpiration, which depends on the heat and the weather and the humidity and the wind and all those things that go into ET. So here's where people get into things like a weather station. And you don't have to buy your own weather station. In many states, certainly most Western states, there are public agencies that publish ET rates, evapotranspiration rates. So these would be a typical rate, or a rate where the weather station is located. California has a great system called CIMIS, CIMIS.
Yep.
And then there's one throughout many of the Western states called the AgriMet system. These are published estimates of evapotranspiration rates. What they'll typically do is give you a reference value, and then they'll give you these coefficients that are based on the crop that you're growing. The reference rate is often just well-watered grass, and the crop coefficient might tell you to take, I don't know, 0.8 of that value for the fruit crop that you're growing, or the grain crop that you're growing. So they'll give you a table to sort of take those reference values and come up with a good approximation of how much water that plant is likely to be using. I did want to mention too something that's really exciting for those listeners in the western half of the United States, which is a new public source of evapotranspiration estimates called OpenET. And this is free. This is now based on satellite imagery. And we'll put a link in the show notes, or you can just Google it, Google OpenET. And what you'll find as you get into this, you sign up, and you can zero in on a particular field, a particular crop field, and it has the evapotranspiration estimates based on what the models and the satellites think is the crop growing in that field. So without having to do any math at all, you can probably get a pretty good guesstimate as to what your ET rates are in your field. That's a real breakthrough and really exciting. And Katherine, you told me you use the CIMIS system quite a lot in California.
Yeah, we did. You can find a weather station near you, and it tracks evapotranspiration estimates on a daily basis or weekly basis or monthly basis. And you can kind of decide how often you want to get these estimates. And for me, I signed up for a weekly email. And so every week I get these evapotranspiration rates of the weather station closest to me. And it comes to my inbox in the form of a spreadsheet. And then I can just plug in the crop coefficient for whatever crop I'm growing. For me, it was grapes. And you do a little bit of math, and then you get estimates for basically how much water your crop is using in your area in a certain given month of the year. And then you can adjust your irrigation rates accordingly. And so it helps to give you a baseline for how much water to apply. But then I would say that the soil moisture monitoring really helps you hone in on the exact amounts, because weather stations, they'll give you estimates, but your system is still going to be its own unique system. And so, it's its own microclimate, your soil's its own unique soil type, and your crop's growing at its own unique rate. So the weather stations are great for giving you estimates. And then when you start monitoring your soil, you can really hone in on the exact amounts of water that your crop is needing. So there are just so many amazing tools out there. And, it kind of takes some time to dial it in, but it's definitely worth it, like you said, Mike, because especially if you're out in a place in the West where water is scarce and water is expensive, it really can help you save money and produce more.
Right. Yeah. So going back to those basics, checking your soil moisture, still check it on site, and that's where you're going to get the most reliable information about what's happening locally. Now, none
Yeah.
of this is very helpful unless you know your irrigation rate. So you got to know Okay, so now I know my crops are using a 1/4 inch of water a day or whatever it is. So I'm going to irrigate once a week. I want to put back 7 times a quarter. What is that? 1 3/4. Okay. But now I still have to know how much water is my system putting out? How long do I need the system to be running? So that's part of the process too, of course. And a really powerful number to know is how many inches per hour, how many inches per minute is my irrigation system applying to the soil. If you know
Right.
that number and you know your evapotranspiration rates, you can really start to dial it in and just replace exactly the amount of water that your crops have used.
Yep. So there's something for everyone. I think it doesn't have to be complicated.
Right. Yeah. The fun of the book was, again, giving people options. So there's not just one thing you do. I think what seemed to me as I looked at a lot of irrigation guidebooks and so on was they often tend to say this is basically an engineering calculation, and so you have to do a lot of math. You have to know your ET rates. You have to do this. You have to do that. So the approach we took was just to sort of free it up and say, well, you got a push rod, that's pretty good. I mean, we know a lot of people that do a really excellent job irrigating with just a push rod. Um, it isn't really dependent on your system. I want to come back and I hope we'll talk about that too. But we know people that do an absolutely wonderful job irrigating with a flood irrigation system,
Right.
with a
Yeah.
furrow irrigation system, with sprinklers, with all kinds of irrigation systems. So whatever you have, whatever you can afford, there are things you can do to run it really, really well. And these are all good tools. So there tends to be a bias towards the expensive, and oh, you got to buy this and you got to buy that. So we sort of push back against that and say, no matter what you have, there are things you can do to run that, to use that equipment to a really high degree, use it really skillfully, use it really efficiently.
Don't have time to stay up to date on the freshest sustainable agriculture news, events, and funding opportunities? You can trust NCAT to keep you connected with our weekly harvest e-newsletter. Subscribe today at ncat.org and get your weekly harvest delivered each Wednesday.
Well, maybe this might be a good time to talk about some of the other myths that there are around irrigation. Because, like you said, I think there's this myth that it's really, really complicated, and it doesn't have to be. So, what are some other myths that are out there about irrigation? I think to start, something that I hear all the time is that drip is always the most efficient of irrigation methods. And there seems to be this sort of unspoken assumption that everyone should be using drip no matter what. Is that true? Are there potential downsides or disadvantages to drip?
Yeah, that's something I hear all the time, Catherine. There are very inefficient drip systems. Drip systems can can be run to a very high level of precision, as you were talking about earlier. That is true, but that takes a really high level of management, a high level of skill, and there are disadvantages and downsides to drip irrigation. One, it's expensive compared to other systems. It's quite expensive to install a drip system, especially on a larger farm. Again, maintenance side, these, as you I'm sure know, these systems are prone to clogging depending on water quality. They need to be maintained really, really well. That takes labor. That takes sort of constant maintenance. Leaks can be a problem.
Yeah.
Um, they don't work well for all crops. They don't work well for all land types. Salinity can be an issue with drip systems. So all these systems have their place, and depending on what you're growing, they can be wonderful. Again, there isn't any one best irrigation system, but certainly drip, if you can afford it, and if you're growing a high value crop, is still sort of that Cadillac. But it is going to take a learning curve, and it is going to take more of a day-to-day intensive management process.
It's very true. And I think with drip, one thing that it's really important to do is to do regular distribution uniformity tests, where you take a random sample size of emitters and you see how long it takes for each emitter to fill up a cup of with water. And ideally, it would take the same amount of time for all emitters to fill up the cup. And that would mean that there's the same flow rate coming out of each emitter, but this doesn't always happen. And so that's why it's really important to regularly do these distribution uniformity tests just to make sure that your drip irrigation system is uniformly irrigating your crop. Because like you said, like if you're not maintaining it regularly, it can actually be more inefficient overall. So definitely important to maintain your system. But I do think that if you do, drip is really great because like you said, Mike, it puts the water right where your crop's root system is. So water isn't being lost through wind drift, and much less is being lost to evaporation. So there are a lot of benefits to it, but yeah, like you said, you just have to maintain it.
And I should have mentioned that the book we did in California is really specific to micro irrigation, by which we mean drip irrigation and micro sprinklers. These are really low pressure systems that do not apply a lot of water. They apply very, very minute amounts of water but they're putting it right at the root zone. And as you said, Katherine, for wine grapes or a lot of high value crops, this gives you super high level of control. You can put exactly the right amount of water that you're looking for.
Yeah, absolutely.
Okay, well, I'll throw one back at you, Katherine. So we've been talking about soil health and organic matter, and something I'm sure many of our listeners have seen is a statement that every time you add 1% organic matter to your soil, like going, let's say, from 2% to 3%, you increase the plant available water by, pick a number. I've seen 20,000 gallons, I've seen 18,000 gallons, I've seen 25,000 gallons per acre. Is that really true?
That's a really, really good question. I think while it's impossible to get those exact numbers, we definitely do know that the higher the organic matter in your soil, the better those soils are at infiltrating and storing water, which does allow you to reduce the frequency and amount of water that you apply. But it's impossible to get an exact number. That number is an estimate. It's going to vary a lot by where you're at, your soil type, but definitely, increasing your soil health and increasing the biology of your soil, that definitely will help your soils capture and store more water because it's creating a better soil structure. When you have microorganisms in your soil, they're basically exuding these glues that hold soil together, and it creates these macropores and micropores, spaces in the soil that then can hold more water in them. Your soil is going to be more fluffy. It's going to have a reduced bulk density. So it is really important to think about that for sure. Is there anything else we should think about when thinking about adding organic matter to our soils? What are some methods that we can use to do that?
Yeah, we're always advocates for the importance of biology. And so we're talking about that and connecting that to irrigation. That's been a missing link. So this isn't just for the engineers, it's not just for the math nerds. It's so important to pay attention to soil health. Things that are familiar and people have seen in all of our publications, including certainly would include reducing tillage, ideally moving towards some type of a no-till system. Cover crops have a wonderful can have a wonderful effect on soil moisture anytime you're adding organic matter, and there's a million ways of doing that.
Yeah, totally. Just getting back to those 5 principles of soil health: minimizing soil disturbance, maintaining living roots, and having diversity of plants, and then having residue on your soil, something to stop erosion. And then, of course, integrating livestock and animals, that also plays a role in increasing soil organic matter and increasing soil water holding capacity. There are so many different conservation practices you could do to increase that organic matter in your soil. And it's going to depend on your context and your crop and everything. And I think, the ATTRA website has, like you said, Mike, hundreds of resources on how you can actually do that. Well, I have another myth that I'd like you to help me work through, Mike. And this is a controversial one. In news stories about water scarcity in the Colorado River Basin, in the Ogallala Aquifer, there's often this assumption that most irrigators are overwatering and are wasting water, or that there are just super easy ways for them to conserve water that they're just choosing to not do. So can you help us work through that?
That's a really good one. And I can only speak from my own experience. But when we were running the irrigation program for that utility in Montana, we were able to measure really, really closely how much water people were putting onto crops. Again, mainly alfalfa. And in that program, which was not a huge number, but maybe a couple hundred irrigated operations we were able to look at, I would say we found about as many underwatering as overwatering. So we were a little surprised. We had assumed that we would find way more overwatering, and certainly many irrigators do. But based on that experience, I would say I'm not so sure. I think
Mm.
people often do the best they can. They do what the neighbors are doing. They may not know exactly what's happening, but the surface of the soil is a pretty mysterious place. So what's happening below there, if you don't do some type of monitoring, it's not always obvious to people. So much as I'm an advocate for irrigation efficiency, and I think it's just so important, it's not going to be, I think, a silver bullet that solves all of our water scarcity problems. And I think most irrigators that I've ever met were and are good stewards and want to take care of the resources, don't want to waste water. But it's more a matter of not knowing quite what's happening, not knowing, not being sure how deep that water is going. I would say with pivot irrigation systems, we found quite a bit of underwatering, and people who change from let's say a side roll sprinkler system to a pivot, often it takes a learning curve, and the application, the water you're applying is much less per hour very often. So again, there's nothing like some on the site soil testing. I mean, stick a shovel in the ground, stick a push rod in the ground, look and see what's happening, how deep that water is penetrating. Anyway, I would just I think you don't know until you really investigate it, and I think almost all irrigators do the best they can, but
Yeah,
I know many of them actually underwater. They're
yeah.
looking for an edge. They're looking to do it better. They're looking to increase their yields. But yeah, it's true. Well, I'll throw one back at you, Catherine. Or I'm not sure this is a controversy as much as we haven't said anything. We've said very little about infiltration, and I know an important distinction that we make again in the irrigator's pocket guide is between the water holding capacity of soil, which is like its that sponge quality, its ability to hold water, and infiltration, which is that downward movement of water, by gravity pulled down into the soil. How can you measure infiltration? Any tips or suggestions on that? And is it important, and or should you even try?
Well, I think infiltration is hugely important. Just being able to get water into your soils is the first part of the problem, and then storing it in your soils is the second part. But first, you really do have to just get it in there. So much of the time, water just rolls off the surface of your soil. And so if you can really create a mulch layer or through some leaf litter, having cover crops is really, really helpful, or some other type of residue on top of your soil, that will help water get in there and then stay in there. And also having living roots in the soil is really important. So roots will create channels in the soil and water can infiltrate down into those channels. So that's how water can get deep into the soil profile. So cover and living roots in the soil, both of those things are really, really important for increasing your infiltration. A simple test can be really, really informative. A basic ring test is the easiest thing you can do, and it just involves getting a metal ring and sticking it down into your soil, filling it up with water, and timing how long it takes for that water to go down into the soil. And if it goes down really fast, that means you've got good infiltration. If it takes a while, that means you might have some compaction. So that can just be something that you do regularly. The most important thing is just to know what your current state is.
Right. I couldn't agree more. If you're just doing a simple ring test, you're not looking for precision. You're not looking for something that's even necessarily that repeatable, because how long it takes the water to soak in will depend a lot on vegetation that's present, the time of year, the temperature of the soil, and a lot of other things. So what you find one day, if you go back and test it a month later, it could be somewhat different. But if you take a ring test in middle of your field and then go do a test in maybe a fenced row that hasn't been plowed and is fairly is healthier soil, that can be really eye-opening. Or if you go back, sort of year to year and just occasionally do a ring test and just see if you're noticing large changes. It's the kind of thing that can give you feedback on whether the things that you're trying are actually working. But there are very expensive, as with anything. You could spend many thousands of dollars on very expensive infiltrometers that will at least theoretically give you precision. But I think for the average person, a good old ring in the ground, cut the ends off a coffee can, or some other simple ring test will probably be really helpful. In the book, we do give you a little more, a few tips on honing that in to get it a little more precise, or translating it into inches per hour, things like that, which might be helpful. Okay, Catherine, well, we touched on some of the potential disadvantages of microirrigation earlier. I'm just curious, since you've done this on grapes, how do the plants react differently to those drip systems compared to the usual type of let's say a sprinkler system or a furrow irrigation system?
Yeah, that's a really good question. And it's true more so for perennials that have deep roots, but you know, we know that plant roots go to where the water is. And so when you're using drip, you're tending to irrigate on a longer irrigation cycle. You're applying a lot of water in one place, and that water will trickle deep down into the soil profile, which is great because it encourages plant roots to go deep down, but it doesn't encourage plant roots to go out. And so, this is something you have to think about. It can be a really good thing when you're wanting your crop roots to go deeper and to tap into those lower soil profiles. But sometimes you do want your crop's roots to go out as well, and maybe tap into some of the O and A horizons of the soil adjacent to that crop. And so, if you want your plant roots to do that, to grow out, drip is not going to encourage that. You just have to think about with these different irrigation systems, where are they encouraging your plants roots to go? And I think along with that, another thing, it's not just plant roots that need water, it's microbes as well. And so both plant roots and microbes go to where the water is. And so, with drip, if you're just putting water into one spot, it means that your microbiology is going to be really concentrated in that one area. But it might mean that there might not be as much microbiology where you're not putting the drip. And so it might take more time for the microbiology to build up, where there isn't a drip emitter. So that's just something to think about. So sometimes sprinklers might be better in your system. So it's just something to think about.
And just to be clear, for those listeners who do have drip systems or micro sprinkler systems, the book we did in California is called the California Micro Irrigation Pocket Guide, and it's specifically about drip and micro sprinklers. So even if you're not in California, I would encourage you to get a hold of that book, and it covers all the nitty-gritty of maintaining those systems, checking for leaks, how to determine how long to run them, and calculating your application rates. These are really, they're run differently, and again, they require that higher level of management.
And that's why I really do think these books are so helpful, because it just kind of spells it out and goes through the things that it's important to think about. So definitely have been very helpful to me, and I hope to others as well. And I guess, obviously we've only scratched the surface here, Mike. There's so much more that we could talk about. We didn't really talk at all about equipment maintenance, and that's a big part of what these books have in them. There are detailed step-by-step instructions for how to keep pumps and motors working. And so there's so much that we haven't talked about, but I feel like we've covered a lot today too. The last thing that I do want to ask you about, so you are the project director for NCAT's Soil for Water program. And so can you just tell us a little bit about what that program has been up to and how that relates to our topic of water conservation and irrigation efficiency?
Yeah, sure. Be happy to. The Soil for Water program started in 2015, so I guess it's been going for about 8 years now. And our mission is to catch and hold more water and soil wherever and whenever we can. We're very interested in learning from land managers and farmers and ranchers. All these things are super site specific, and there are dozens, hundreds of things you can do to catch and hold more water and soil. I mean, of course, including a lot of the soil health methods we've been talking about, but we're really impressed with the ingenuity and a lot of experimentation that's going on farms around the country. And so a big part of what we do is support conversations, and we have a forum where people are welcome to chip in their latest questions or their latest ideas or the latest on-farm experiment. So we're supporting do-it-yourselfers who are trying new things to catch water in their soils. And listeners who are interested, we'd love to have you join our Soil for Water network. You can just go to our website, which we'll put in the show notes, but it's soilforwater.org, soilforwater.org, and or join the forum, which you can also find from our website. And the other thing I would say about that is we've always felt that soil health had a lot of relevance to drought and to the challenges of dealing with water scarcity, and that it was sort of a missing piece when we talk about drought. Yeah, we do talk about irrigation efficiency very often, and we'll talk about things like pipelines and dams and moving water around differently. But soil health needs to be part of that discussion as well. And we still believe it can be one of the most effective things people can do on their own place to cope with dry times and low water availability. And that's the message we're really bringing to the whole discussion of drought and resilience and water scarcity is what can we do with better soil management that can help people get by with less and cope with what they have. What's new in that program is we are taking a big interest in the Colorado River Basin and extreme challenges. I'm sure everyone has seen those amazing photos and videos of the big reservoirs along the Colorado River, which are so low, even with the big snow year we've just had. And so bringing this message of better soil health and relating it to drought and working with people to try to learn better ways and more site-specific ways of catching and holding water. And then, of course, the Ogallala Basin is the other one, which is in such great need. And we're rapidly seeing not only farms, but whole communities that are looking for alternatives as the water they're tapping through their wells in the Ogallala. They keep needing to go deeper and deeper. Cost is going higher and higher. So again, not to say that soil health is going to be a silver bullet to solve all these problems, but we think it has a lot to contribute. So anyway, what we would love to have we believe in peer-to-peer learning. We don't have all the answers. We are learning as much from producers as we are from the experts and the university people. And we would just love to have anyone who's got an interest in the water holding capacity of soil or infiltration to check out our Soil for Water website or join our network and join the conversation.
Well, that's wonderful. It really is such a great program. And this has been such a fun conversation. I've really enjoyed talking with you about soil health and how we can be better irrigators.
It's been fun, Katherine, and thank you for your help as a reviewer on these new publications as well.
That's it for this episode. Thanks for listening. Additional information about this episode and related resources can be found at attra.ncat.org. Don't miss an episode. Subscribe to Voices from the Field wherever you get your podcasts. I'm your host, Rich Myers. ATTRA, Voices from the Field, is produced by the National Center for Appropriate Technology, headquartered in Butte, Montana. It's supported by the USDA Rural Business Cooperative Service as part of NCAT's ATTRA Sustainable Agriculture program. Any opinions, findings, conclusions, or recommendations expressed in this recording are those of the participants and do not necessarily reflect the views of the USDA or NCAT. We'll catch you again next week, and until then, keep on farming.